In the world of modern physics, reputations are built slowly and destroyed quietly. Peer review decides what is possible, and institutions decide who is heard. Most revolutions never announce themselves. They are dismissed in hallways, rejected in journals, and ignored in offices with oak panel walls. This is a story of a young man whose work was never meant to survive those rooms. A student without pedigree, funding, or institutional protection, and an equation that should not have existed. What follows is not a celebration. It is an examination of how close modern science came to discarding something it could not afford to ignore. His name, according to university records, was Arjun Malhotra. He arrived at Harvard not through legacy admissions or elite preparatory schools, but through a scholarship so narrow it was almost symbolic. He came from a village in eastern India where electricity was intermittent and textbooks were shared between generations. His father repaired radios. His mother taught mathematics at a local school. Arjun learned early that knowledge traveled slowly where he lived and authority traveled faster. By the time he reached Cambridge, Massachusetts, he already understood that silence often carried more weight than argument. Harvard's physics department did not notice Arjun at first. He attended lectures quietly, rarely asked questions, and submitted assignments that were technically correct but stylistically unconventional. His notation was unfamiliar. His assumptions were sometimes unsettling. Professors marked his work with polite concern. Mathematically interesting, one wrote, but physically misguided. Another suggested he focused less on theory and more on established frameworks. In a department defined by lineage and citation counts, Arjun's ideas did not arrive with the correct credentials. That alone was enough to make them suspect. The first real conflict emerged during a graduate seminar on quantum field theory. Arjun presented a derivation that attempted to reconcile inconsistencies between relativistic space-time curvature and probabilistic wave behavior. It was not entirely new, but his approach reframed the problem using boundary conditions drawn from thermodynamics rather than geometry. The room grew quiet. A senior professor interrupted him halfway through. The criticism was not cruel, but it was final. "This line of reasoning leads nowhere useful," he said. "We resolved this decades ago." The discussion moved on without Arjun. After that day, Arjun became invisible. Invitations to collaborate stopped. His advisor began suggesting safer research topics. When Arjun submitted a preliminary paper to an internal review committee, it was returned with a brief explanation. The math was correct, they said, but the conclusions violated too many accepted constraints. One reviewer added a handwritten note. "This is not how physics advances." There was no formal reprimand, only a quiet redirection. In elite institutions, dismissal rarely arrives as rejection. It arrives as guidance you are expected to obey. Arjun did not obey. He stopped attending social events and remained in the department long after midnight. He worked not from defiance, but from necessity. The inconsistencies he saw in modern physics were not philosophical to him. They were structural. Equations that worked in isolation collapsed under unification. The standard explanations felt incomplete. He began developing a mathematical construct that treated space-time not as a continuous fabric, but as a probabilistic lattice influenced by entropy gradients. It was an idea most physicists considered unproductive. Arjun considered it inevitable. When his advisor discovered the direction of his work, the conversation was brief. Arjun was told his funding might not be renewed if he continued. The department could not support research that risked reputational credibility. There were careers at stake, journals to consider, donors who expected orthodoxy. Arjun was advised to revise his dissertation topic or seek opportunities elsewhere. For the first time since arriving in the United States, Arjun considered leaving without finishing. He returned to his apartment and began calculating on paper because his laptop had finally failed. The equation emerged slowly over months of isolation. It was not elegant in the traditional sense. It linked entropy, curvature, and probability in a way that suggested space-time itself behaved like a thermodynamic system approaching equilibrium. If correct, it implied that certain constants assumed to be fundamental were emergent properties instead. The implications were severe. Entire models of cosmology would require revision. Arjun understood this. He also understood why no one wanted to hear it. His equation did not offer solutions. It demanded reconsideration. Arjun submitted the equation to a mid-tier physics journal under pseudonym. The rejection came in 11 days. The reviewer dismissed it as speculative and internally inconsistent. Another suggested it was mathematically clever, but physically irresponsible. The paper was never circulated beyond that committee. Arjun printed the rejection and folded it into his notebook. He had expected this outcome. What he did not expect was the anomaly he discovered while stress testing the equation against black hole entropy data. The model predicted a measurable deviation that existing equations could not account for. That deviation corresponded to an unresolved discrepancy in observational data collected years earlier. It had been cataloged, acknowledged, and largely ignored because it disrupted too many assumptions. Arjun's equation did not eliminate the discrepancy. It explained why it existed. He reran the calculations repeatedly, convinced he had made an error. Each time, the result persisted. This was not proof, but it was something more dangerous. It was consistency. Arjun knew that if he was wrong, he would be dismissed. If he was right, the silence would be louder. With no institutional support left, Arjun uploaded the paper to an open-access preprint archive. There was no announcement, no outreach. It sat unnoticed for weeks. Then a postdoctoral researcher in Eastern Europe cited it in a footnote. A physicist in South America emailed Arjun asking a single question about boundary conditions. Within months, quiet discussions began appearing in obscure forums. No one referenced Harvard. No one mentioned the author's background. The equation circulated without context, evaluated only on its internal logic. That was the first time it survived scrutiny. Harvard noticed the paper only after a senior faculty member was asked about it during an international conference. He dismissed it publicly as derivative speculation. Privately, he requested a copy. When he realized the author was one of their own former students, concern replaced curiosity. The department convened an informal review. No minutes were taken. No conclusions were published. The question was not whether the equation was correct. It was whether acknowledging it would destabilize existing work funded over decades. Silence remained the safest option. Meanwhile, independent simulations began aligning with Arjun's predictions. The deviations his model suggested appeared in newly analyzed datasets. Nothing conclusive, but enough to make dismissal harder. Journals did not publish retractions. They published cautious commentaries. Arjun was not invited to speak. His name appeared only in citations, often misattributed or truncated. The equation began to acquire a nickname, stripped of its origin. This is how controversial ideas survive institutions. They are separated from the people who created them. Arjun returned to India after his visa expired. There were no job offers, no acknowledgments. He taught mathematics at a regional university with limited resources. At night, he continued refining his work. He was no longer trying to convince Harvard. He was trying to understand the consequences of being correct. If space-time was emergent, not fundamental, then gravity was not a force but a statistical tendency. That idea alone challenged entire branches of physics. Arjun suspected the resistance was not intellectual. It was existential. Years later, a major research collaboration announced experimental results that aligned unexpectedly with entropy-based spacetime models. The press release avoided specifics. Commentators spoke of new directions and unifying perspectives. Arjun's equation was cited deep in the technical appendix. By then, it was no longer controversial. It was inconvenient. Harvard never issued a correction. No apology was made. The professors who dismissed him retired with full honors. The institution absorbed the discovery without acknowledging the rejection that preceded it. Arjun watched the announcement online from his office in India. He did not celebrate. He recognized the pattern. Science did not reject his work because it was wrong. It rejected it because it arrived from the wrong place, in the wrong voice, without the protection of authority. His equation did not break modern physics in a dramatic collapse. It fractured it quietly, forcing adjustments no one would openly attribute to him. That was how revolutions occurred, when they threatened the structure that enabled them. Students began encountering the equation in advanced coursework, presented as part of an evolving framework. No origin story accompanied it. Arjun's name appeared rarely, often misspelled. The narrative had been rewritten. The underdog was unnecessary once the idea could stand on its own. Institutions prefer discoveries without disruptors. They are easier to manage. Arjun continued teaching, answering emails from young researchers who sensed something familiar in his work. He never warned them. He believed experience was the only credible teacher. Harvard eventually invited Arjun to attend a symposium as an observer. He declined, not out of resentment, but clarity. The institution that dismissed him no longer defined the value of his work. His equation had already escaped its origin. That was both its victory and its cost. Authority had not been overturned. It had adapted. The system absorbed the anomaly and continued, slightly altered, without acknowledging the resistance that delayed understanding. The story was never about Harvard. It was about how knowledge moves through power, about whom is allowed to challenge consensus and who is expected to comply. Arjun's background made him invisible until his ideas became unavoidable. By then, credit was negotiable. The equation remained. Its implications continued unfolding slowly, reshaping models without dramatic announcements. That is how modern physics changes, not through confrontation, but through quiet correction. Arjun never claimed to have broken physics. He understood that science does not break. It resists, adapts, and rebrands. What his equation broke was an assumption that authority guarantees insight, that institutions recognize truth on merit alone. His story revealed something less comfortable, that even in disciplines devoted to evidence, power decides timing, and timing decides history. Today, the equation exists in textbooks without context. Students solve it without knowing the risk it once represented. Arjun remains a footnote when he is remembered at all. He does not mind. The work was never about recognition. It was about resolving a contradiction he could not ignore. The cost of ignoring it would have been greater than dismissal. That calculation, more than any equation, defined his career. If there's a lesson in this story, it is not inspirational. It is structural. Systems reward conformity and tolerate disruption only after it becomes useful. Arjun's journey was not exceptional because of brilliance, but persistence. He continued not because he believed he would be validated, but because the math demanded completion. That is the quiet engine behind most scientific revolutions. Not ego, not rebellion. Responsibility to coherence. Harvard did not fail because it rejected Arjun. It failed because it believed rejection was neutral. Institutions often mistake caution for objectivity. In doing so, they delay understanding and reassign credit later. The cost is not only personal, it is intellectual. Progress slows when authority mistakes stability for truth. Arjun's equation waited patiently for relevance. Reality eventually provided it. The story ends without justice or closure. That is intentional. Most real disruptions do not conclude with acknowledgement. They conclude with absorption. The underdog disappears. The idea remains. That is how systems protect themselves while evolving. Arjun returned to his work each day, aware that recognition was unpredictable, but understanding was not. He chose the latter. Years from now, historians of science may trace a subtle shift in physics back to an obscure paper uploaded without institutional backing. They may never mention the meetings where it was dismissed, the emails that went unanswered, the advisor who suggested safety over truth. That erasure will not be accidental. It will be efficient. History prefers clean narratives. Arjun still writes equations by hand. He still believes clarity matters more than acceptance. When asked by students if institutions ever apologize, he answers honestly. Institutions do not feel embarrassment. They feel pressure. And pressure, applied slowly, changes behavior without confession. That understanding has served him better than recognition ever could. The equation continues to appear in research, quietly adjusting models of gravity and spacetime. Its origin is rarely questioned. Its utility is undeniable. That is how ideas win without acknowledgement. They become necessary. Arjun watches this from a distance, not detached, but realistic. He never expected applause. He expected resistance. That expectation made survival possible. In the end, no professor was punished. No policy was changed. No apology issued. Modern physics adjusted itself and moved forward. The underdog returned to obscurity. Authority remained intact. Only the math changed. And in science, that is the most disruptive outcome imaginable. This story is fictional, but the pattern is not. Across disciplines, ideas are filtered through power before evidence. Progress does not fail because of ignorance. It slows because of comfort. Arjun Malhotra exists as a composite of many unheard voices. His equation represents the cost of delay, not personal cost, collective cost, because the most dangerous discoveries are not the ones that are wrong. They are the ones that are right too early, spoken to quietly by people the system was not prepared to listen to.